All right, here is some help on the Chapter 14 review. So in class I mentioned you're on your own for page 1. You should be able to do that. On page 2 I asked what do you need help with, and the questions that came up were C, E, and F on number 3. So let's have a look at those. So, oh my gosh, I don't have my glasses. I left them at home. Can I see this? Oh my gosh. What does it say? The limit as x approaches, oh my gosh, positive infinity, I think is what it says. This is terrible. Can't see anything. What if I zoom in? I'll use the magnification. Oh, now I can see it. Okay. As x approaches positive infinity, what happens to the function 5e to the negative x plus 9? Okay, so we can just substitute in our positive infinity in for x. So that would give me 5e to the negative. Notice the negative is part of the formula. I put in my positive infinity plus 9. Okay, e to the negative infinity. E is like the number 3. Okay, it's 2.72. But what if I had 3 and I raised it to a negative big number, right? Because infinity is a big number, a negative big number. So like negative 1,000. Well, a negative exponent is the same as writing 1 over 3 to the 1,000th. So 1 divided by 3 raised to the 1,000th, well, 3 to the 1,000th is some humongous number. 1 divided into like a trillion little tiny pieces. How big is each piece? Basically 0. So this part right here approaches 0. This is approaching 0. So 5 times 0 is 0. 0 plus 9 gives me 9. So if I were to graph this, if I was to graph this equation here, notice I have a vertical shift of 9. So this function would be approaching a horizontal asymptote at 9, because the whole thing is shifted up 9 units. Okay. So notice how I approach this. Since e is a little bit scary, I changed it to a 3. And since infinity is a little bit scary, I changed infinity to 1,000. And then I was able to think about it a little bit easier. Okay, letter E. Notice on this one, I can factor out an x, because notice I want to take the limit as x goes to 0. So if I put in 0 right now, it's not helping me so much, because I'd 4 times 0, I'm dividing by 0. And remember, if you ended up with dividing by 0, you've got to pick a number really close to 0 to test it. But since I'm trying to do this without a calculator, I'm going to go ahead and factor out the x's. So on top, both of these terms have an x, so I'm going to factor out an x, and I'm left with 3x plus 8 over 4x. Now I can reduce x divided by x is equal to 1, so that goes away. So I'm left with 3x plus 8 over 4. Now I can substitute in my 0. So 3 times 0 plus 8 over 4. 3 times 0 is just 0. Oh, I just noticed I'm a little too zoomed in. Can't see what I wrote over there. Let's zoom out. There we go. So 3 times 0 is 0, plus 8 is 8. 8 over 4 is 2. So this one actually reduces down to 2 because I was able to factorize this and before I substituted in my 0 for the x. So notice this one is not going to infinity. The x is not approaching infinity, so I can't use my rule of, oh, bigger degree on top in the numerator than in the denominator, therefore it goes to infinity. I can't use that rule because I'm not going to x is approaching infinity. I'm going to x is approaching 0. So be careful about the shortcut rules. Those only work for x approaching infinity. So next one, this one, notice x is approaching negative 2. If I were to plug negative 2 in right now, I'd end up with 0 in my denominator. So this is another situation where I want to look to factorize. So on top, I'm going to show you how I do factorizing, for those of you having a hard time with it. X squared plus 8x plus 12. What I do is I list out the factors of x squared. I just list them underneath it. X times x is x squared. And then I list out the factors of 12 underneath 12. Two numbers that multiply together to give me 12. And I'm looking to somehow combine them to get an 8. So I'm thinking 6 times 2. And then I can cross-multiply these, and if I cross-multiply them, I get 2x and 6x. If I add those, I get 8x. So I know I'm good. But when I write this down, it's going to be x plus 6 times x plus 2. So on top, I have x plus 6 times x plus 2. On the bottom, I've got x squared minus 4. That is a difference of 2 squares. Again, I could make this little thing here, x squared minus 4. And I could do, okay, that's x times x. 4 is 2 times 2. In order to get a negative here, one of these is going to have to be negative. And then notice what happens when I cross-multiply this. 2x times negative 2x. So I get 2x times negative 2x. And if I add those together, the middle term disappears. Okay, here 6x plus 2x gave me the middle term 8x. Here 2x plus negative 2x. See, those cancel out. That's why there's no middle term. So x squared minus 4 is x minus 2 times x plus 2. So this is kind of a cool little method of factoring that I like very much. So now I can reduce the x plus 2 over x plus 2, and I'm left with x plus 6 over x minus 2, and I've kind of run out of room because I used all my room for my factorizing. But let's go ahead and see if I can squeeze this in. I'm approaching negative 2, so negative 2 plus 6 over negative 2 minus 2. Notice I don't have 0 in the denominator anymore. I get positive 4, positive 4 over negative 4, which goes to negative 1. So my answer is negative 1. Okay, my answer over to this one was positive 2. Let's zoom out now. There we go. So those are the ones that people were asking for. Okay, next problem. Discuss the behavior near its asymptotes, okay, of this function. So notice this is a rational function. So this should look familiar, 4x minus 1 over 5x plus 3. And it wants us to deduce the equations of the asymptotes. So it says discuss the behavior near its asymptotes. Well, where are our asymptotes? We want to find the equation of the asymptotes. And we want to draw a sketch. So the asymptotes are going to happen, if we think about it, if I sketch a little graph, rational functions do this kind of thing, right? They do that, sort of an exponential on one side and kind of an exponential on the other side. So I want to know what happens when x gets really, really big. So when x gets really, really big, where is my function going? So if x gets really, really big, the negative 1 and the 3 kind of don't matter anymore. So I'm left with 4x over 5x. And then the x's are going to cancel out. So if x gets really, really big, I'm going to be left with 4x over 5x, because if this is like a million, 4 million minus 1, who cares about the minus 1? And I put in a million for x, 5 million plus 3, who cares about the plus 3? Now I can reduce out my million over a million, and I'm just left with 4/5. So y equals 4/5 is where I'm going to have a horizontal asymptote. So I'm going to go ahead and put that in. And so I know that because I was thinking about the behavior of this function when I put in a really big number for x. So this is going to be y equals 4/5. Now, to get the vertical asymptote, I need to know what is x not allowed to be. So x is not, or rather the denominator is not allowed to be 0. So I know that 5x plus 3 is not allowed to be 0. So what can I, oops, where is it? There it is. 5x plus 3 cannot equal 0. So if we solve this, I get 5x cannot equal negative 3, divided by 5x cannot equal negative 3/5. That is going to be my vertical asymptote. So at negative, I guess I need to zoom out a little bit more so I stop cutting off my work. Negative 3/5 is going to be over here somewhere. So that is x equals negative 3/5. Notice I didn't put the little slash there because the equation, the asymptote is what does it actually equal? X actually equals negative 3/5. righty. Okay, so I have my asymptotes, but to draw the sketch, I need to know where are the little pieces. See how these are my normal little pieces? I need to know, are they going to be here and here, or are they going to be more like in the second quadrant and fourth quadrant? So to do that, what I like to do is find the y-intercept. So if I put in 0 for x, I can find the y-intercept. So the y-intercept is when x is equal to 0. So I'm going to put in 4 times 0 minus 1 over 5 times 0 plus 3. 4 times 0 and 5 times 0, well, those are just 0, so I'm left with negative 1 over 3. So my y-intercept is going to be at negative 1/3, so that's going to be somewhere around here. See, that's negative 3/5, so I'm kind of on this fractional scale here. So this is negative 1/3. So that tells me that my pieces are going to be like this and like this. And that's good enough for a sketch. I just need to know, like, where are those pieces. So there's my sketch. We also could have found the x-intercept by changing y to 0. That would have been easy enough. Well, what the heck, let's do it. So the x-intercept is when y is equal to 0. Why did I write that backwards? I don't know. So taking my equation, 0 equals 4x minus 1 over 5x plus 3. Multiply both sides by 5x plus 3. Well, 5x plus 3 times 0 just cancels out. So I'm left with 0 equals 4x minus 1. Add 1 to both sides. Divide by both sides by 4. I get 1/4 is equal to x. So, and that makes sense right there. That's 1/4. And there you have it. Okay, so there's my sketch. Ta-da. Okay, next, sketch the graph of e to the 4 minus x plus 6. Okay, this reminds me of what we had up here. So we know that as x goes to infinity, as x goes to positive infinity, this whole thing is coming down to the horizontal asymptote. So I can see my horizontal asymptote right here. I'm going to have a horizontal asymptote at 6. So I'm going to put in, call that 6. So that's y equals 6 is my horizontal asymptote. Now I'm going to think about this in terms of transformations. Let me zoom in on that so I can see it. 4 minus x, I'm going to rewrite this as e to the negative x plus 4 and then plus 6. And I can think about this as, first of all, it's exponential decay. If I put in a negative number in for x, I put in a negative number here, minus a negative becomes a positive. So if I put in a negative y value, a negative x value, I'm going to end up with a positive y value, a big one, a really big one. Okay. So I do know that the as x goes to positive infinity, just like this problem up here, I'm going to, since I have that negative sign in front of the x, as x goes to positive infinity, this will go to negative infinity, and e to the negative infinity is like nothing. So I know it's going to end up like skimming along this way to the right. Oops, sorry, you can't see that again. Where am I? It's going to end up skimming down here. So we need to know, well, how about the y-intercept? Let's find the y-intercept. That's going to be helpful. The y-intercept is when x is 0. So e to the negative 0 plus 4 is just e to the 4th plus 6. E to the 4th, remember e is around 3. So 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So it's going to be way the heck up there. So it's going to start up really high, and then it's going to come down. Okay? So, and that's going to, it's going to go, and you can put in negative values for x, so this would keep going. There's no vertical asymptote. I can use anything for x. So there is no vertical asymptote. Okay? But that's approximately it. All right, now find the limit as, this should have said x, not h. Find the limit as x goes to negative infinity, because my variable here is x, right? Isn't that an X? I gotta zoom in again. I can't see anything without my glasses. Yes. So sorry, that was a typo. I want to know what happens when X goes to negative infinity. Is that why you were all confused on this? Maybe, maybe not. Maybe it doesn't matter. Okay, so if I put in negative infinity here, I'm going to have minus a negative. And so that's going to become a positive. So this is going to be e to some really big positive value. And so that's just going to infinity. Okay, so and we can see that on our graph as well. As x goes more and more in the negative direction, what's happening to my y value? It's going up, up, and away. So what's happening here? This just equals positive infinity. That's it. I don't even really need to do any work there. I mean, if you wanted to, you could substitute in. You could say e to the 4 minus negative 1,000, if you will, plus 6, which would give me e to the 1,004 plus 6. Well, e to the 1,004, that's like 3 times 3 times 3 times 3 times 3 times 3. Oh my gosh, forever. That's a huge number. So, and as you put even bigger and bigger numbers in for x, this is just going to get bigger and bigger, so it's going to infinity. Okay, and the last one, what does that say? Positive infinity. Well, that is going to the right. So we already kind of talked about this one. Since we have that horizontal asymptote, I'm just going to get closer and closer and closer to y equals 6. So what is the limit as h goes to positive infinity? And that should say x. I am so sorry. That should say x. As x goes to positive infinity, what should happen? The whole thing is approaching 6. It's approaching that horizontal asymptote. So let me zoom out a little bit. Okay, and again, we could show a substitution. This would be e to the 4 minus a really, really big number. So that would be e to the negative 996. And when I have a negative exponent, that's 1 over, and e, I can change that to 3, 996 plus 6. This is basically 0. 0 plus 6 gives me 6. So there it is. There is my limit. All right, differentiate from first principles. Okay, use the formula, the f of x plus h minus f of x, all divided by h. Same thing here. Number 8, you should all be good to go. Seen that a million times. All right, so here we go. Here's some review. So this is actually really useful for what we're going to be doing tomorrow. We have a weird-looking function, 3 to the x squared minus 7 times 3 to the x minus 18. And I'm being told that it can be rewritten as a binomial times a binomial. Notice this is like a trinomial, and I'm going to write it as a binomial. That kind of reminds me of what we did over here, where I had a trinomial, and I wrote it as a binomial. So what did I do? I factorized it. So let's look at this again, but this sure looks awful strange. Wouldn't it be nicer if this said just x squared minus 7x minus 18? That would be so much easier. So that's what we're going to do. We're going to do something called U substitution. We're going to use the letter U to represent the thing that's kind of bugging us, which is, I don't even know what that is. I got to zoom in. I can't see it all. 3 to the x. So this 3 to the x is kind of bugging me. I don't like that. So I'm going to call U 3 to the x. Now, everywhere I have a 3 to the x, I'm going to change it to the letter U. So I'm going to have U squared minus 7, there's a 3 to the x, so I'm going to change it to U, minus 18. Now I'm going to factorize this. Let me zoom out a little again. Okay, so doing the technique I used before, U squared is U times U. 18, I can change that into, that's going to help me get a 7, that's probably going to be a 9 and a 2. In order to have a negative 18, one of these has to be negative, and I want more negatives than positives to get a negative over here, so I'm going to make the 9 a negative. Now, if I cross multiply these, I get 2u and negative 9u. So 2u plus negative 9u equals negative 7u. So here is my factorized form. it's going to be u minus 9 times u plus 2. And we could multiply it out to double check that that actually works, and it does. And now we can go ahead and substitute back in my u. So u, I said, was 3 to the x. So everywhere now that I have a u, I'm going to put back in my 3 to the x. So I get 3 to the x minus 9 and 3 to the x plus 2. Now it says to find the values of a and b. Notice they have plus signs here. They have plus signs. So I want to rewrite this one as a plus. So I'm going to change it to plus and negative. So that way what I have here matches there, and now I can see what a is. A is equal to negative 9 and b is equal to 2. Or you could have switched them. You could have said a is 2 and b is negative 9. Okay, so this answer, or with them switched, would be fine as well. And that's it. And z means integers. The letter z, I gave you a packet with all these symbols, and z means integers. So in other words, no fractions. We wanted an integer, and we found integers. All right, so hence, oh, there's more to this problem. Hence, find the exact solution of the equation when this whole thing equals 0. Okay, so now I'm going to take my factored form. When it says hence, it means use what you just got to use in the next part. So I'm going to take my 3 to the x plus negative 9 times 3 to the x plus 2 equals 0. So I'm going to take what I did, the work that I did, and notice this is the zero product property. I have two things multiplying together to give me 0. That means either the first thing, 3 to the x plus negative 9, has to equal 0, or the other one, 3 to the x plus 2, has to equal 0. Okay, so let's see. If I try and solve this, I move 9 to the other side, so I get 3 to the x equals 9. 3 to what power equals 9? Oh my gosh, what could that be? How about x equals 2? Hopefully you can just do that in your head. 3 squared equals 9. And then this one, I'm going to minus my 2, and I have 3 to the x equals negative 2. Okay, I have a 3. If I raise it to an exponent, is that going to change its sign? No, there's no exponent in the world I could put on a base of 3 that's going to change it to a negative number. It can make it big, it can make it small, but it's always going to be positive. So this one is not possible, so I throw that one out. So there's only one answer here. X equals 2. Isn't that magical? All right, how long is this video going? Oh my gosh, I'm at 23 minutes already. Holy cow. All right, moving on. Okay, these are pretty straightforward. I just need to simplify this. First of all, the parentheses aren't doing anything because there's no exponents outside the parentheses. So I'm going to go ahead and just drop the parentheses. I have 5 times m times n to the 8th times 6 times m squared, and then times n to the negative 3. Okay, so I can multiply my coefficients together, 5 times 6, because I can rearrange them. Everything's being multiplied, so I can rearrange them. I can put this up front, 5 times 6. I'm going to then put my m's together, so times m squared, and I can put my n's together, n to the 8th times n to the negative 3. So I'm doing this very systematically and slowly. Some of you, if you can do this, you don't need to watch my video, right? Fast forward. 5 times 6 is 30. M times m squared is m to the 3rd, because this is 1m, and m squared is m times m. So how many m's do I have? I have 3. So that's m to the 3rd. Okay, the n's, if you're not sure what to do with the exponents, the shortcut is add them. But if that throws you off, you can rewrite the negative exponent as division. So this part right here, I'm going to do this up here. This is the same as n to the 8th divided by n to the 3rd. Now, just to go back to what this means n 2, 3, 4, 5, 6, 7, 8 multiplied by itself 8 times, and on the denominator I have n times itself 3 times. I can then reduce these, and what am I left with? N to the 5th. So, of course, what are the shortcuts? What is the shortcut? Is that plural or not? All I got to do is add the exponents, and I get n to the 5th. Okay, so there's that one. The next one, I kind of like rearranging everything. I like rewriting my negatives as positives. I also like distributing my exponent here. So whenever I see a negative exponent, it only applies to the number or letter that it is directly on. So this -3 does not affect the 2. Okay, it only affects the x. And same here, this -3 down here only affects the y. It doesn't affect anything else that's next to it. And then I'm going to move their positions. When I move those positions, the exponent changes its sign. So let me move that out of the way. So on the numerator, I still have my 2. I still have my y to the 5th. But now I also have this y to the 3rd. And in the denominator, I still have my 4x cubed squared. And now the y to the -3 is gone, but I'm moving this one down, so I'm going to have x cubed. Okay, next thing I want to do is get rid of these parentheses. The 2 on the parentheses means repeat the parentheses twice. So on the denominator, I'm going to have 4x cubed times 4x cubed. And then I still have my x cubed from out here. Oops, let me move that over, sorry. 4x cubed squared, I multiply it by itself 2 times, and I have my x cubed. On the numerator, let's go ahead and simplify that. That's 2y to the 8th, because I have 8 y's being multiplied together. Now I can simplify the bottom. I have 2y to the 8th over 4 times 4 is 16. And I can count up all my x's. I got 3, and another 3, that's 6, and another 3, that's 9, x to the 9th. And finally, I can reduce my 2/16, that would be 1/8. So I have 1y to the 8th over 8x to the 9th. And I don't have to write that 1. I could have just written y to the 8th over 8x to the 9th. There's that. And now I've run out of room for this one. Okay, so this one, all I have to do is distribute to simplify this. Oh my gosh, I can't not see this at all. Let me zoom in. What are those numbers? Okay, so remember I'm multiplying this times this, but when I multiply my bases and with exponents, if they have the same base, I keep the base and I add the exponents. So since these both have a base of x, I can add the exponents. So I have 1/2 plus 1/2. So this first term is x to the 1/2 plus 1/2, which is 1. The next one, I keep the coefficient, so -2, because this only has a coefficient of 1, so 1 times 2 is 2. And then I have 1/2 times, what does that say, 3/2? That means I add them, right? I'm going to add my exponents. So 1/2 plus 3/2 gives me 4/2. 1/2 plus 3/2 equals 4/2. 4 divided by 2 is 2, so that gives me x squared. And then 1 times 3 is 3, and now my exponents, I have to add my exponents. 1/2 plus -1/2. So 1/2 plus -1/2. Oh, that's just 0. So x to the 0, what is x to the 0? Anything to the 0 is a 1. So that's times by 1, which is just 3. So here's my answer. See, I didn't need a lot of room for that. And I don't need to write that exponent of 1. I could have just written x. And if you want to, you can rewrite it in a more standard order, which would be -2x squared plus x plus 3. Okay, so the key here is that when we're multiplying a power time like this, same base, we add the exponents, just like we did over here. M times m squared, this is m to the first. M times m squared, I add the exponents. That's how I got m to the third. N times n with their exponents, I add the exponents. And I just keep the base. I don't mess with the base. All right, next one, solve the following equations. So notice I have 4 with, oops, where is it? Come on. Here we go. So I have 4 raised to this equals 1 over the square root of 2. Can I rewrite this with an exponent? I think so. So the square root of 2, another way of writing that is 2 to the 1/2. So, oops, let me change that a little bit. So I have 1 over 2 to the 1/2. Okay, roots can be written with fractional exponents. And let's keep going on this. This then, to move this to the top, I can change my exponent to negative. So that's the same as 2 to the negative 1/2. Okay, so now I've rewritten 1 over the square root of 2 as 2 to the negative 1/2. 1/2 means it's square root, negative means it's in the fraction. Now the 4, I can rewrite that as 2 squared. But now I got to keep my exponent, which I need to zoom in on because I can't see it. Oh my God, what does that say? It's so tiny. 2x plus 1? I think that's a 2x plus 1, or is it a 2x minus 1? Yep, it's plus 1. Gosh. 2x plus 1. Okay. Now I'm going to go ahead and set my exponents equal to each other. See how the bases are the same? That means this exponent must equal this exponent. In order for this side to be the same as this side, if the bases are the same, the exponents have to be the same. So negative 1/2 equals 2 times 2x plus 1. And then I'm going to distribute that and solve. Oops, now I'm too zoomed in. Okay, I'll let you take it from there. So you can finish that. That's just basic algebra at that point. Okay, same idea for B. So I'm going to let you do B. I'm not going to do it for you, but I'm going to tell you, you're going to rewrite 125 as the power of 5. And then just like I did on this one, change it to a negative exponent. And then you should have the 2 sides of the equation written with the same base, so therefore you can set the exponents equal to each other and solve. So I'll let you do that. All right, the last one, let f of x equal the square root of x, and let g of x equal 2 to the x. Solve this equation. So notice I have a bunch of things going on here. I need to first find the inverse function. F to the negative 1 means the inverse function. That means I'm going to take this and I'm going to rewrite it with y. And then I'm going to swap the x and the y. So to get the inverse function, I need to swap the x and the y. So I'm going to have x equals square root of y. And then I'm going to I'm still so zoomed in. And then I'm going to resolve for y. So to get rid of the square root thing, I'm going to need to square both sides. So I get x squared is equal to y. So the inverse function of square root of x is x squared. So f negative 1 of x is equal to x squared. That is the inverse function. So that's this part. G of x is right here. So now I'm going to do my composite. F negative 1 composite with g of x. I want to do my composite function next. So the one that's closer to the x is the one I start with. So I start with 2 to the x, and I'm going to place that in for x in my inverse function. So here, instead of x, I'm going to write 2 to the x, and then I'm going to square it. Notice I have a power on a power, so I can simplify that. So that's equal to 2 to the 2x. Now, they tell us that this whole thing equals 0.25. So this equals 0.25. Now, like we did in the previous problem, it would be nice if I could write this with the same base. So let's change this 0.25, let's change that to a fraction. You should recognize that that's 1/4. 1/4 is the same as a quarter. Oh, money, quarter. Amazing. All right, rewrite this as 1 over 2 squared. You see, they're starting to look more and more alike. Now I got to move this up, so I've got to change the sign of the exponent. So 2 to the 2x is equal to 2 to the negative 2. Now look, my bases are the same. Where am I? My bases are the same. I can set my exponents equal to each other. So 2x equals negative 2. Divide both sides by 2. I get x is equal to, I'm still so zoomed in. Let's see the whole thing. I get x is equal to negative 1. Oh. Holy cow, what an awesome problem. Okay, so that is great. I love this problem. Inverse function, composite function, exponents, rewriting with the same base. Fabulous. And we did all of that without ever touching a calculator. Amazing. And it only took me 35 minutes. Bye.